Okay. All right, scholars, we are here now, or are we nowhere, right? Anyway, congratulations, guys. You know, you made it to you made it to a major checkpoint. This is our last official class, right? No, it's not. No, it's not. Sorry, getting a little ahead of myself. We got one more after today, right? Uh, yeah, I think we still have Wednesday. Yeah, so let's not jump to that. Let me see, just things that are important. I've updated everybody's grade over the break, right? I think that it pretty much includes everything except the final. I think. Matter of fact, let me check real quick. Let me just hop and check. So if I go to grade book, manage, and managing completes. That includes, yeah, everything except the final. All right. Yeah. Turn it. I lost my page. Yeah. So I think you know the spiel. I can't think of anything else. Does anybody have any burning questions before we kind of get into the content? Going once, going twice. Oh, the final. So, there's good news. I will be proctoring your final. So basically, what that means is that it'll be just like our exams 1, 2, and 3, like our previous exams. So it'll become available. Let's pull that up to be official. It should be. Let me see if this week is the reading period. So it should become available this Sunday, and it's due Friday, December 8th at 11:59 p.m. Also, that Friday, December 8th at 11:59 p.m. is the hard deadline for all assignments. Let me just confirm and make sure. But yeah, I think I scheduled it for this Sunday. All right. And let me say this. there is a common final out right now. Like if we were, like there, we really are supposed to be having a common, but I think you would prefer for me to proctor because the common final, even though it's the same stuff that we talk about, it's a completely different format. We might have to be in person. It has to be graded by hand. I think this is way more simple, right? You know, it's just like how we did other exams. It's just cumulative. It's from the beginning of the semester to the end. It becomes available. It should be this Sunday, the 3rd at 11:11 a.m. and is due Friday, December 8th at 11:59 p.m. Unlimited attempts. There's no late penalty. It's the hard deadline is that Friday. So that not only includes the final, but that's all assignments, right? So that's the hard deadline for all assignments. Okay, I hope everyone had a happy holidays, and I'm proud of you guys. I just want you to know I am proud, no matter where you are, because this is not easy, right? Even if we were in person, I know people feel like it would be easier, and maybe it is slightly, but not significantly. Even when we were in person, students would still struggle. You're still responsible for the work. You have a human being right there in front of you, but you still have to do the work, right? And it's harder. Indirectly, it's actually harder on you guys because it's harder on me. And when it's harder on me, then it amplifies on you guys, right? I kind of act as like I don't know, some kind of like a buffer or something. But if it's harder for me, then it's harder for you guys because I just had to get up like hours ahead. I had to feed myself on the go. It's just totally uncomfortable. It's just like, and then it's like it makes me cranky. If I'm cranky, then I'm less like, able to like be available. So because this is more favorable for me, then I can do my best to be as available as I can for you all, and be more gentle, like grading, and like be creative, and more fluid, and like responses, and stuff like that. But I am proud of you guys. This is not easy. This is not for the faint at heart. And you've essentially done it. You survived it. You did it, right? So now you just need to take it. Like whatever it is that you want, the glory, the good grades, whatever it is, it's sitting literally right there just waiting for you to take it, right? The spiel about I encourage you all to like collaborate. I think it's totally okay. In this day and age, I think it's fine. It's not just, learn whatever you can from the experience, but do what you need to do to get through, right? Okay, guys. So I do want to try to maximize our time on the study guide. And again, if you have questions, feel free to unmute yourself to get my attention. I want to go back to this view. Yes, yes, yes.
Are you still allowing other Pearson assignments to be turned in, or is it final after you did put the grades in?
Yeah, everything, everything is available.
Okay,
Every
so I have an assignment. I think you already graded, but I'm gonna do it again.
Yeah, yeah, yeah. That's fine because
Can I
I'm
still
gonna
do it?
yeah,
Or something?
yeah,
Okay.
yeah, because I'm gonna recalculate the grades after that hard deadline. So I just did that grade update just to give you a snapshot of where you are at that moment in time. It has no bearing on your final grade, right? So
Okay, thank you. 'Cause I didn't do one assignment. I saw like the grade and I'm gonna do it real quick.
was it an exam?
I don't know. But I
I
know
mean,
it was one of the November assignments. I didn't do it yet.
it's fine. Yeah, just yeah,
Okay, yeah, I'll do it probably like today or tomorrow.
it's fine. But I'm not gonna update grades until after the eighth.
Yeah, that's fine. I just want to make sure I can still do it.
Yeah. Okay. All right. So let's hop into this study guide. Let's see. Yeah. Yeah, we had the holidays. We had like some cousins come over. It was real chill. I slept a lot. I just, you know, I enjoy my like personal time gaming. Now, this is probably not the best, but I discovered like a new life hack. Like so, like recently, I go to Quick Trip, and like I for some reason I just stopped throwing away like Quick Trip cups. I get these like large, the extra large drinks, but I try to like water them down a little bit so it's not so much processed sugar. Um, but I use them like around the house for like random stuff. And then I got to thinking, I was like, it doesn't make sense to keep getting these cups. I was like, you should be able to refill it. And so when I was pumping my gas last time in Quick Trip, the clerk was coming around like, doing stuff. And I was like, yo, do y'all have like a collector's cup or anything where I can like refill my drinks? He was like, yeah, you could just bring whatever cup you have and there are discounts on the refills. I was like, bet. So I brought my cups and like these two giant cups. Normally it's already cheap. It's like less than $3 for these two giant cups. When I refilled it, how much did I pay? I think it was like $1.30. No, it was less than that. It was like 80 cents. It was like less than $1 for these two giant cups of drinks. I was like, oh crap, new life hack unlocked, new hack unlocked. So anyway, so if you ever a Quick Trip, if you bring your own cup, they give you discounts on refills. So I usually take these cups when I go to the movies. When I go to the movies, I'll fill it up and put it in my backpack. And they, as of late, they just let you bring what you want into the store, into the blankets, and I'd be bringing like meals and drinks and everything I want because the prices at the movie theater are like ridiculous. But I do have the what is it called, the Stubs thing, where it lets you see 3 movies a week, which is about the right rhythm. So that's what I do a lot of times. I like to pay for things like get subscriptions, so I only got to make one payment a year. Now, honestly, if I was the owner, if I had things, I would have packages that would be like a weekly package, a monthly package, a yearly, or like a quarterly package, a yearly package, a 2 year package, something extended. I have so many ideas and plans. I don't even know where to begin, but I am going to be working on them over time. Like another idea that I thought was fantastic, and then we'll get on task. Um, I always had this vision, and I'm just giving it out because I don't know if I don't mind if somebody takes it. I just want to see it exist. Um, but basically, it's a community where like you pay for everything up front, right? Like you can pay for 5 years at a time or 10 years at a time, and that includes like all utilities and food. You don't, so that way everything is covered for the next 5 years. You don't have to worry about it. You just come home, or there could be a chef in the cafeteria. You need food, you go get it, right? Like you don't have to stress. Like I was like, that would be dope. And then another one is like I had the idea, but I know that people are already doing it, where you build communities of tiny houses, right? And you can rent them out, like on Airbnb and stuff. So, like tiny houses, I could have bought one by now if I hadn't thought about it. You can buy a quality, like a luxury tiny house for like $10,000, and then rent it out on Airbnb and be charging whatever you want. Like some of the rates that people charge on Airbnb are ridiculous, but people pay it because they're traveling. When they travel, they'll spend that money. So those are just a few little nuggets if somebody could take it, create it, maybe you can like be taken care of for generations. Okay. All right. So let me see. We got what? 1 through 110. All right. Let's get back on task. And I'll check the thing in just a moment. Let me see. Give me nope. Um, 98. Okay, we'll start with 98. And I want to check here one more again. Get these gentlemen. All right. Let them in. Let's see what we got. Yep. No, I don't know how many questions on the final. But I mean, it's unlimited attempts, right? So if you finish it, it's just like the previous exams, maybe 20. Let me see if I can look it up. I'll look it up. You get unlimited attempts, right? So let me see. If I go to manage, let me see. That's a little bit of a hint there. I'll let that be. Look like it's 25 questions. Okay. So take that or leave it. No, I could change that, and I probably should, but it's okay. I'm probably not going to. Yes, I think you guys have done enough. I just need you to finish. All right, let's see. I might change it in the future though. Again, it's all kind of based on my mood. All right, you said 98, right? So we'll start with 98. All right, chill. Okay. All right, so it says sketch the graph of the function and check the graph with a graphing calculator. Before doing so, describe how the graph of the function. So this is basically transformations of functions, right? We have this f of x equals e to the negative x minus 1. So the base function is e to the x. Remember the exponential function here. Matter of fact, let's just go ahead and pull it up. So let's use Desmos, right? Or whatever your favorite graphing calculator is. And we're going to pull it over here to the side like that. And we are working. Okay. So the function e to the x, we'll say y equals e to the thing. Y equals e to the power of x, right? So this is the shape of a basic exponential function. Notice it has a horizontal asymptote, right? In this form, the x-axis serves as a horizontal asymptote, going off to negative infinity, and then going off to positive infinity, y tends to positive infinity. So then we have these two transformations. We multiply x by negative and we subtracted 1. Now, once upon a time, I used to factor out that negative, but that doesn't seem like it works. What seems like it works, like if we take this and multiply x by a negative, if you multiply the inside by a negative, it should flip it horizontally, right? So then we should have exponential decay. And then if we subtract 1, we should move it to the right by 1. So let's actually just type it here. We'll say negative x minus 1. Whoops, not there. Minus 1, like, nope, aren't you? There it is. Minus 1, no. You just refuse to work. All right. So this negative x minus 1, there we go. All right. Negative, So if we do horizontal, did we move it to the right? It looks like we moved it to the left. We definitely moved it to the left. Let me see something. I just want to see how they explain this one. I mean, we can get it right here. Let's do it first. Shift the graph of e to the x. Oh, this thing off. Shift the graph of e to the x. If we go right and then Let's go right one because they haven't a shifted first, right? In the end, we want it to be to the left, right? If we move it left first and then flip it, it's going to be in the wrong orientation. You know what? Let me think. Yeah, right? I think this is where we flipped it. We moved it to the right by one, and then we flipped it horizontally. Yeah, yeah. Let's try that because that's what it's looking like. Still kind of okay. Move it to the right one units and then reflect it about the y-axis. Okay, so I'm gonna check this, but before I move forward, before I graph, I want to click on the view and example. I just want to see how they explain as far as the ordering, right? Note that the given function is an exponential function, right? Siri, turn the heater off. The graph of this can be obtained from the graph of this basic exponential function, right? To graph this, start with the basic exponential function to the right. The graph of this is the graph of this shift this many units right. Okay, so they just did x minus 6 first, and then they multiply by the negative on the inside. Mm-hmm. Okay. Okay. Yeah, that's fine. So they did the horizontal shift first, and then they did the reflection, right? So again, the -1 says to go to the right by 1, and then when you do f of negative x, that flips horizontally. So I think that the order is basically the same way we introduced it, right? We did our rigid transformations first, which was like shifting up, down, left, or right. Then we did reflections in the x or y axis. Then we did our stretching. I'm trying to think. That should be fine. Let's go ahead and do this graph, right? Move on. So this graph, I'm just going to click. Let me see. We're going to go to the right by 1 and then reflect across the y-axis. Let's see, is that correct? That is correct, right? Save. Check. Okay. That was it. Let's do another random number. I really like this thing that makes it so much easier. 109. I think we did 109 already. Let's see. From last time. We'll do it now. Solve the given system of equations. So they're doing U substitution. I am going to try. I think we did that last time and it worked, right? So let's see if we can get it to work, just in the interest of time. 1 over x plus 1 over y equals 10. Ooh, that image is funky. 2 over x minus 4 over y equals 8. Okay. So we are trying to see where these guys cross. Are those the only two places? Think so. Looks like one is the origin. I don't know how to get this. It used to work. Now it's not really working. Well, the origin can't be it, right? X and Y can't be 0. So whatever this other point is, we might need to just solve it. Yeah, and then it looks funky. Yeah, and it's not giving me, but it looks like that point right there. 0.125. Siri, what's 0.125 as a fraction?
0.125 as a fraction is 1 over 8.
So it looks like it's 1 over 8 comma 1/2. Notice if we plug in 1 over 8 and a half for y, we'll get 8 plus 2 is 10. And then 16 minus 8 is 8, right? So those definitely work. The origin doesn't work because you can't divide by 0. So let's try 1/8.5. If anybody wants to see the algebra behind that, just say so, and we'll work it. We can work it out by hand. Okay. What's the time? Did we just do 97? Okay. So this comes from section 3.1, question 49. Find the amount that results from the given investment. $20 invested at 11% compounded continually. Okay, let's use a calculator. Calculator. So here. Pull it to the side just like the other one. Find the amount that results from the given investment. It says 20% invested at 11% compounded continuously. Continuous compound interest. So whenever you see continuous compound interest, that's PERT, right? P E to the RT, right? So the formula is here: A equals P times E to the power of RT. See the PERT? Okay. So our principal is $20 times E to the power of the rate. 11% as a decimal is 0.11 times 4. Okay. And that's what we're going to type in the trusty, dusty, rusty calculator. Ooh, my brain is off. It's like, hey, it's time to get caught up on some anime, right? That's what I do in the holiday season. That's the only time of year that I'm like, you know, I can kind of focus on an anime or whatever. Last year, and my cousins were in town, and so they suggested what did she suggest? It was some weird movie. It was about these orphans trying to escape. I think it was on Netflix, because they realized that like every time a kid was getting adopted, they really weren't getting adopted. They were being eaten by like aliens or something. It was wild. So these little children are plotting to escape. Like anime is crazy. Like if you have the most like wild storylines. I definitely got to get caught up on like Attack on Titans and stuff like that. Okay, anyway. 20. Why are you still typing there? Come on. 20. You just refuse. Let me see. Oh no. Oh no. Go back. Come on, buddy. I don't know how to get this to work. There we go. Yeah, I did that. Anyway. E is S. Nope. Second S. Okay. E to the power of 0.11 times 4. 0.11 duplicate 4. Okay. Close parentheses. Okay. So we got, and it says round to the nearest cents, $31.05. Why? I do not like questions like this. when the numbers are so small. 31.05. All right. Let's do another random. Question 5. That is random. Okay. Graph the equation. Oh, easy peasy, lemon squeezy. Doors open, beds made. Welcome home. Y intercept is 7, right? So I'm just going to click in 2 random spots, 1 and 2. And then I'm going to drag them to where they need to be. The y-intercept is 7, so I'm just going to drag this till it says 0, 7. And then if the slope is 3, so that means we go up 3 and over 1, now we should be at 110. So the second point is at the order pair 110. Boom, just like that. Save and lock and load. Okay. Why? What is going on with 97? Did you just give us 97? Maybe I was seeing the future a little bit. Because at first I was like, didn't we do that already? And then we did it, and then they gave it to us again. So maybe that was a premonition. Let's look at 99. Starting with the, let me make it a little bit bigger. starting with the graph of y equals e to the x, use transformations to sketch the graph. Okay, right. So we have, let me see, I see 1, 2, 3 transformations altogether, right? We're starting with y equals e to the x. And again, the recommendation when we do multiple transformations in one go is to work our way from the inside to the out. Start with the innermost transformation and work your way out. The innermost transformation is where we multiply the x by negative. So that's going to flip it horizontally, right? So now we're going to have an exponential decay. Then we multiply the outside by a negative. So that flips it vertically. It's like the y's go from positive y to negative y, right? So now, first we had exponential decay. Now you flip it upside down, right? So you have the exponential decay, but it's upside down. And then we added 4, so that moves the whole graph up by 4 units, okay? So I'm going to click to enlarge. I'm going to click on this one. That's not exponential. Exponential is here. Third row left. And I'm just clicking anywhere on the graph. Now we said we flipped it horizontally over the y. Then we flipped it vertically over the x. Then we did a vertical shift up 4 units, just like that. Okay. Save. Oh, let me see. They might want us to sketch a horizontal. If it marks it wrong, okay, never mind. The horizontal asymptote is y equals 4. What's the time? Y equals 4. Let me check on you guys in Zoom. Make sure I got his credit. All right, guys. Generate 35. Let's go to question 35. Determine algebraically whether the given function is even, odd, or neither. So even, odd, or neither in terms of function, we had to evaluate f of negative x, right? Whenever we have, let me just write it out. I'm trying to explain it audibly. This is one that definitely makes more sense if you just write it out. That's pretty smooth. Okay. All right. Oh, good talk. So, quick recap. Do I have one ready? So the definition of a function being even. Whenever we evaluate f of negative x, we get back to the original. A function being even is the same as a y-axis symmetry. Another way you can articulate this, whenever you have x comma y, you also have negative x comma y, right? So the definition is the first line, and then the last 2 lines are some properties that come with a function being even. A function being odd, let me a function being odd means, I guess I could just copy and paste. It's fine. Whenever we evaluate f of negative x, we get a negative times f of x. Right? Okay. A function being odd is the same as origin symmetry. And so another way you can articulate that is that whenever you have whenever you have x comma y, you also have negative x comma negative y. So all the points are equidistant and symmetric about the origin. With the even function, all the points are equidistant and symmetric about the y-axis. So these are the definitions of a function being even or odd. So for our function, we need to change x to negative x, simplify, and then see do we get either of these two cases, right? 5x squared plus 6. Again, we're replacing x with negative x. Okay, so that's going to be 5x squared plus 6. So notice we have g of negative x equals g of x. That's the definition of a function being even. You could guess, right? You could guess. Originally, you got, looks like it's 3 choices. So you get a 33% chance of being correct if you guess. But chance favors the prepared mind, right? So may the odds forever be in your favor. Speaking of odds being in your favor, I did recently see that if you liked Hunger Games, the Hunger Games series, they came out with a new movie called Hunger Games, The Ballad of Songbirds and Snakes. That was actually decent. It had that classic feel to it. I enjoyed it. It was kind of like showcasing the evolution of snow. So yeah, if you get a chance to go, just some free marketing for them, right? But I enjoyed it. I wasn't even thinking about it. I just like, oh, there's a new movie. I was like, okay, let's check it out. Let's look at question 17. Let's hang out for like a little over 5 minutes. Right here. Find an equation of the line that passes through these points. Use the equation to determine whether these 3 points are collinear. Let me see. How can I? There we go. Yeah, I was avoiding trying to write it, but I think we need to write this one. Let me zoom in some so I can get a better view. That's decent. And so like I recently experienced something else where I had this idea eons ago, like when they first came out with like VR goggles, I was like, why are they keeping it confined to like the virtual reality? Why not put some lenses in it and do AR goggles that do this? And now I think the metaverse does that. I was like, damn it. But that kind of stuff has been happening to me my entire life. I have these ideas and then I don't take action on them. And the next thing you know, it's in reality somebody else took action, and they're capitalizing on it. But I was like, one of these days, I will move on one of these ideas. All right, but yeah, and then the next level after that, but they already kind of showcased it in Black Mirror. So you have VR goggles where you can only see the virtual reality. Then you have AR goggles, which stands for augmented reality, where it basically takes the virtual reality and overlays it onto actual reality. So you're basically augmenting reality. So like imagine playing a shooter game, but you can have like guys popping from around the corner in your house or up your stairs or in your woods or whatever. So you can see your reality, but you're playing like a game, right? So that you're not limited to the virtual space. Like you can, I think that's dope. But the next level beyond that is now you start getting into micro technology. That's where Black Mirror went in. And it was like, okay, well, instead of it being goggles, what if it was an implant? And it gets creepy. Because then the people you think you're being lied to now and you're being deceived. Imagine if you had that chip. And yeah, you can play the game and you can do cool stuff, have the hive mentality. Like imagine having the internet in your head. It has a lot of really cool features. But it also opens up the stage to more ways to be manipulated and lied to and bamboozled and taken advantage of, right? It's tomato kind of thing. So, but yeah, if you haven't seen the series more free marketing, if you haven't seen the series Black Mirror on Netflix, you definitely want to check that one out too. That one's really trippy. That first episode is really wild. You definitely want to get past that one. Maybe by like at least get to like through episode 4 and you'll get a strong sense of but the first one is different than the others, but then beyond that, they're like the near future. And like, I don't know if it's real or not, but I saw where this company was claiming, like, I don't know if you've seen this series called Altered Carbon, where they can load your consciousness into like a sleeve. So apparently, there's a real company that claims that they can do that. Now, I personally don't believe it. I feel like, when they start taking people's consciousness and loading into the virtual reality, I feel like that the person is gone. I feel like that might be a copy of their memories, and that they might be able to like behave like the person. But as far as I'm concerned, that's not the actual person. That's just a copy of the person. So I would never do it. Like, no, I'm good. Because I think that if I were to sign up for it, that would be it for me as far as my authentic self, right? That copy of me might live on, but me, who I am, so I'm going to be somewhere else. That's just how I feel about it. Find an equation of line that passes through these points, right? Okay. So we have 2 points. So whenever I'm working with lines, this is going to be the last one. Whenever I'm working with lines, there are 3 formulas I like to have ready to go. The slope formula. Let me see, change in y, so that's y2 minus y1 over x2 minus x1, and that's our slope, right? Then we have the slope-intercept. Y equals mx plus b. And then you have your point slope. Now, I generally don't use the point slope, but it doesn't hurt to have it. Y minus y1 equals m times x minus 1. So with these 2 points, we're given 4, 7, okay, and 7, 10. So whenever I'm given these ordered pairs, I like to just label them automatically, x1, y1, x2, y2, okay? So then if we wanted to find the slope between these 2 points, it's going to be 10 minus 7 over 7 minus 4, 3 over 3, which is 1, okay? And then I like to use the y equals mx plus b. And I'm going to choose the first point just because the numbers are smaller. So my slope is 1, and x is 4, so 1 times 4. My b is what we're solving for, and y is 7. So then b equals 3. So it looks like the equation of line is going to be y equals x plus 3. Right? So notice when x is 4, we get 7. When x is 7, we get 10. All right? So this is the equation of line through those two. So then for these to be collinear, -2 comma 1 needs to be a point on this line. So when x is -2, nope, that's not -1, right? That's a positive 1. Which is not equal to -1, right? So are these, sorry. We're good, right? -2, yeah, that's what we wanted, was +1, right? Okay, so we are good. Told you my brain shuts off this time of year. So are they on the same line? We would say yes. Go ahead and submit this result. We got y equals x plus 3. We got yes. All right, gentlemen, are there any burning questions before we go our separate ways? If you join us late, I will be hosting the final, right? So it'll be just like our exams 1, 2, and 3. It's unlimited attempts. It'll become available this Sunday at 11:11 a.m. and you have until the following Friday, which is December 8th at 11:59 p.m. That December 8th at 11:59 p.m. is the hard deadline for all assignments. So, hopefully, idealistically, you've already gotten your Pearson where you wanted to be. If not, you still got about right now it's like almost 2 full weeks. Almost. It's not this Friday, but it's next Friday. So you could be, idealistically, you want to have completed all assignments before you start the final. That way, when you submit your final exam, you're done, right? You don't want to have a whole bunch of lingering stuff that you're trying to submit once you finish your final. Are there any other burning questions before we go our separate ways?
Yeah, I got a question.
Give me just a split second. We are going to meet on Wednesday. Wednesday is our last official day. Okay, go ahead.
All right, so like, let's say we got like a 70 on the assignment when we first did it. If we do it now, can we get like a 90? Like on
Yeah. Yep. Yep.
every single assignment, even if it's like weeks
Yep.
old.
Yep.
Uh,
Because there's at most a 10% late penalty. So any assignment that you want, if you just keep doing it until you get the highest you can earn on the late assignment is a 90, and I have students that do it, and that's within our regulations or whatever. So yeah, as long as you get it in there, it'll show up.
All right. Yeah. Also, I was wondering. So I finished my ALEX course. Is our grades after we took the ALEX post test gonna be updated or?
Yeah, that'll be updated when I update after the hard deadline. So yeah, yeah, I get that from my colleague Dr. Lamar, and I use that to factor into your final grade.
All right, cool. Wait, how much percentage is the ALEX of our grade?
So the Alex lab counts for 10% of your overall grade.
Okay, thank you.
Any other burning questions before we go our separate ways? Going once, going twice. All right, gentlemen. Again, I'm proud of you
Excuse
guys.
me.
Yes, go ahead.
Could you reiterate the hard deadline?
Friday, December 8th at 11:59 p.m.
Okay, thank you.
All right, gentlemen. So we have one more session. We'll meet again on Wednesday, same time, same place. I'm proud of you guys. You didn't come this far to just come this far. So finish strong, guys. All right. Take care. Enjoy the rest of your day. And from one beautiful mind to another, peace.